Okay, dissolution process. The general idea of dissolution process is a process by which solid, liquid, gas dissolve in a solvent to form a solution. For example, you have a solid, you have sugar. So sugar dissolve in water to form a solution, air gula. Okay, so your solid is sugar, water is the solvent, so you mix together, so it will form a solution which is air gula. Okay, so when you have liquid, for example concentrated syrup macam ibu syrup macam tu, so the concentrated syrup or any cordial, okay, or any cordial is liquid. Okay, so dissolve in water, so you mix with water, you mix with solvent, so it will form a solution. Okay, so that is the general idea of dissolution. But here we want to talk about dissolution process of ionic solid. So ionic solid is actually referring to salt. Okay, for example, you have sodium chloride salt. So sodium chloride, between sodium and chloride, you will have ionic bond. So you have Na plus and Cl minus. So that's why we call it as ionic solid. Okay, another example, magnesium chloride. So between magnesium and Cl, you will have ionic bond. So that's why we call it as ionic solid. Okay, so this process by which ionic solid dissolve in a solvent to form a solution. Okay, so how is the process? So water is a polar molecule and most ionic crystal are soluble in water. So ion in a solid crystal can be separated. So what will happen first? It will be separated to become Na plus gas and Cl minus gas. And then next, this gaseous ion will be surrounded by water molecule. So here you have Na surrounded by water molecule. So from gaseous state, it will transform to aqueous state. So same goes to Cl minus, surrounded by water molecule. The difference is if you have Na, so this Na will connect to the O from water. So Cl will connect to the H from water. Okay. Okay. So before we look at the process, we need to learn about lattice energy. So we have two different versions of lattice energy. The first one is formation. The second one is dissociation. For formation, lattice energy formation, energy released when 1 mole of solid ionic compound is formed from its gaseous ion. So 1 mole is referring here. So 1 mole of solid ionic compound is formed from its gaseous ion. So 1 mole of sodium chloride formed, it will release 771 kilojoule energy. So this one will form from its gaseous ion. So that one is formation. So for dissociation, energy required to completely separate 1 mole of solid ionic compound into its gaseous ion. So 1 mole is referring here. So you want to separate between Na and Cl. So it will form gaseous ion. So for formation, the value is negative. For dissociation, the value is positive. Okay, so lattice energy could be formation, could be dissociation. So how to determine whether this lattice energy is formation or dissociation? We look at the value. Because for formation, the value will be negative because it is referring to exothermic reaction. Okay, so reverse to the formation. So reverse to the formation is, so this is the reverse to the formation, is dissociation. So that's why this one is positive and endothermic. The value are the same because this is a forward and reverse reaction. So lattice energy could be positive, could be negative, depending on the value given. Okay, but normally in SK015, normally in your final exam, question will give you lattice energy negative value, which is referring to formation. Okay, normally. Okay, so when I have solid ionic compound, for example, I have salt, and then I dissolve the salt in water, and then I stir, the salt will disappear. So where did the salt go? How from the salt that you can touch, it disappear in water. So actually there are two processes happen here. So the first one, the salt will separated into positive charge and negative charge in gaseous state. So this one is referring to lattice dissociation. Lattice dissociation, which is endothermic reaction. So the salt will break, separated into two ions. So and then the ion will be surrounded by water molecule. Okay, so that's why from gases it will become aqueous. So this solution process is actually adapting Hess's law idea. Okay, so according to Hess's law, when reactant converted to product, so here in this case, okay, here in this case, when reactant converted to product, delta H will be the same if the reactant take one step or if the reactant take series of steps. Okay, so dissolution process actually we apply idea from Hess's law. Okay, so delta H solution, so enthalpy of solution. So this is your salt. Okay, this is your salt. This is your salt. You can touch your salt. So this is actually your air garam. Okay, so this is garam boleh pegang. Garam boleh pegang. Ini adalah air garam. Ini adalah air garam. So, dissolution process actually referring to enthalpy of solution. Okay, so as I mentioned just now, the salt will break into two ions. Okay, so the first step, the salt will break. How the salt will disappear? So the first step, the salt will break into ions, gaseous ions. Okay, so this one is referring to lattice dissociation enthalpy. So this one should be always positive. Always positive. If the question give you lattice energy in negative, you just positive the value. Okay, and then the gaseous ion will be surrounded by water molecule. So it's still in form of ion. It's just from gaseous state transformed to aqueous. Gaseous state transformed to aqueous. So this one is referring to enthalpy of hydration. So according to Hess's law, enthalpy of solution, okay, equal to lattice energy dissociation plus with hydration. Okay, so solution will be the subject. Okay, so hydration is referring to the positive charge and then this one is referring to the negative charge. So please remember, this one is always positive value because it is referring to dissociation process. Okay. Okay, next we look at example. So example 1, given the data, construct energy cycle diagram to represent dissolution of NaCl and then calculate the lattice energy. So we start off with NaCl in form of solid. So when it dissolves in water, it will form a solution. So this is your solid. Okay, this is your solute. Okay, dissolve in water, it will form solution. So this is basically your solution. So this one is referring to enthalpy of solution. So in the cycle, we will write down positive 6 and the unit will be kilojoule. So you need to write down delta H solution equal to positive, the magnitude Okay, 6, and then the unit is kilojoule. We only write down kilojoule in the cycle. Okay, so what actually happened? So Na and Cl will break into gaseous ion. So this one is lattice dissociation. Okay, this one is endothermic reaction. Endothermic reaction. Okay, and then it will be hydrated. Okay, so given hydration for Na is negative 390 kilojoule. So you need to write down kilojoule only. So for chloride is negative 380 kilojoule. So this one is actually lattice, and please remember this one is positive value. So according to the Hess's law, enthalpy of solution is equal to lattice plus with hydration of Na plus with hydration of Cl minus. So we insert the value, so you will get positive 776 kilojoule per mole. Please remember your final answer should be kilojoule per mole, the unit. You need to have plus 776 kilojoule per mole, because definition of lattice is 1 mole of sodium chloride dissociate into its gaseous ion. So it is referring to 1 mole of something. So that's why we write down unit kilojoule per mole. So in the cycle, you just write down unit kilojoule. So for example 2, based on the data given in table 1, construct an energy cycle diagram for dissolution of lithium chloride. So you only need to construct. So based on the data given dissolution of LiCl, lithium chloride. So dissolution process is a name of a process which is referring to enthalpy of solution. Okay, so you need to write down completely. So lithium chloride in solid, dissolve in water, becoming lithium ion, aqueous, chloride, aqueous. So in the cycle, you need to write down delta H solution, and then the unit will be kilojoule. In the cycle, the unit will be kilojoule. And then you need to write down positive or negative value. Okay, and then given the lattice energy of lithium chloride, so this is negative value, which is referring to formation, but in dissolution process, we want to dissociate. We don't want to form, we want to dissociate. We want to dissociate the ionic compound. Okay, so the lattice energy should be positive in dissolution process because you dissociate. So if the question give you negative, you just change the sign. Okay, and then the hydration for lithium, and then hydration for chloride. Okay, next example. Enthalpy change for 1 mole of barium chloride is dissolved in water to form a solution is positive 75 kilojoule. So when the question already mentioned 1 mole of barium chloride dissolved in water to form a solution, so this one is referring to enthalpy of solution. And then the unit is kilojoule because here we have 1 mole. Okay, so in the sentences, we have mentioned 1 mole of this one. So that's why the unit is kilojoule. Okay, but actually this value is referring to enthalpy of solution. If I transform this one into a mathematical expression, okay, it should be positive 75 kilojoule per mole. Okay, because it's already mentioned 1 mole. Okay, so 1 mole of barium chloride, so this is your salt, dissolve in water to form solution. So this is your solution. But you need to balance the equation. So here you have 2Cl, so you need to have 2Cl here. Okay, so this one is referring to solution. So in the cycle, we only write down unit kilojoule. Okay, so that's the first data given. The enthalpy change for lattice of barium chloride is negative 965 kilojoule. So given lattice energy, so this one is for formation, but what happened here, this one will dissociate, okay, becoming gaseous ion. So you will form 2Cl minus gaseous ion. So from this value, you just change the value to positive. Okay, because this is formation, this is dissociation. So in dissolution process, it is referring to dissociation, lattice energy dissociation. Calculate the hydration of barium 2 plus ion if the enthalpy hydration of chloride is negative 210 kilojoule. Okay, so we would like to calculate hydration of barium. So given enthalpy hydration of chloride. So this one should be 2 times because from 2 mole of chloride gas becoming 2 mole of chloride in aqueous phase, because by definition negative 10 kilojoule per mole is referring to 1 mole. 1 mole of chloride ion, the 1 mole negative 2 negative 210 kilojoule per mole is referring to 1 mole. 1 mole of chloride ion in gases hydrated. So this value is referring to 1 mole. So here you need to have 2 mole. So this value need to times 2. So 2 times negative 200 kilojoule. Okay, so according to the Hess's law, so enthalpy change will be the same if the reactant take one step, so referring to enthalpy of solution, or if the reaction takes series of steps. So lattice dissociation plus with hydration of barium, so we would like to find this value, and then plus with 2 times delta H hydration of Cl minus. So I write down 2 times, okay, here. So we just insert the value. So 75,956 plus with hydration. So we would like to find this value. And then, okay, so and then 2 times negative 210. So your answer is negative 470 kilojoule per mole. Again, the unit should be kilojoule per mole because it is referring to 1 mole of barium ion in gaseous state hydrated. So it's referring to 1 mole. So that's why your final answer is kilojoule per mole.